Hi folks, and welcome back to Math with Captain Rod. Making this video here to go through some examples of how to graph logarithmic functions. So what we're going to do right now is we're going to sketch a graph of log base 2 of x. And the way we're going to do that is first we're going to write it in exponential format here. Gotta get my pen on. All right, so this logarithm can be written 2 to the y equals x. These are basically equivalent statements. Again, what a logarithm is it's the solution of this equation here. And what we're going to do now is we're going to build a table here. X, y. Now, generally speaking, you almost always pick x's and calculate y's, but this one is set up a little bit easier to pick y's and calculate x's. So I'm going to go ahead and start just picking some values for y and putting them on the graph. Let's start at y equals 0. So if we put 0 here, 2 to the 0 is 1. So this thing goes through the point 1, 0. Let's try 2. Whoops, put that in the wrong place. I can't get my back button there. I guess we'll just erase and go back to pen. Every time I do this, I got to change. There we go. All right, so we're going to put in y equals 2. 2 squared is 4. All right, so this goes through the point 4, 2. 1, 2, 3, 1, 2, 3, 4, 1, 2. All right, let's try 3. 2 to the third is 8. So this goes through the point 8, 3. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. All right, we can start to see, the shape here. Now let's kind of investigate what happens over here. Let's try -1 just to see what happens. Whoops, again, for y, not x. So if I put -1 in, what we're going to have is 2 to the -1, right? X is going to equal 2 to the -1, which is 1/2. So this goes through the point 1/2 minus 1, so 1/2 minus 1. Let's try -2 for y. And then x is going to be 2 to the -2, which is 1 over 2 squared, which is 1/4. So 1/4 -2, so 1/4 -2. And you see what's happening is this graph is approaching the y-axis here. And in fact, it never can touch this axis. And the reason is there is no value you can put here for y that's going to give you a 0 here. So the y-axis is actually a vertical asymptote for this graph. So if I sketch it, I can sketch the rest now. This graph is looking something like this. And again, let's talk domain and ranges. This graph is not defined for any value over here because there's nothing you can put in for y that's going to get you a negative number out. So the domain of this function is x has to be greater than 0. The range of this function is, let's see, all real numbers really, because this goes straight down to -infinity, and it keeps going up and to the right forever as well. You can put any value in for y you want, 100, a million, a billion, you're going to get a number out. Right? And there's a sketch right there of this, which is equivalent to this function, y equals log base 2 of x. And again, let me do a little reminder of, what is this thing? Well, it's this, it's the inverse of an exponential function here. Let me use green here. And look at what happens when we plot the inverse of this function, right? This thing went through 0, 1, so the inverse would go through, I'm sorry, this went through 1, 0, so the inverse would go through 0, 1, and then 2, 4, and then 3, 8. And then -2, 1/4. And that's probably enough to sketch it. I'm going to go ahead and sketch this in green. All right, so these two graphs we have that we're looking at here. Right, this one is a graph of y equals log base 2 of x. This one is a graph, and by the way, this is equivalent to this. And then the inverse of this would be y equals 2 to the x. Okay? And you'll notice that these graphs are symmetric about y equals x. So that's what a logarithm is it's the inverse of an exponential function. So this actually didn't ask for this one in the notes, but I put it in there because, again, I think it's important to talk about, to link what is a logarithm. So, again, the domain of this function, is x greater than 0, range, all real numbers. Let's take a look at another one here. All right, this one's got a little more going on, but not a ton more. First step in graphing it, let's write this 3 to the y equals x minus 4. Whoops. Wait. Try that again. 3 to the y equals x minus 4. So x, if we were to solve this for x, is going to equal 3 to the y plus 4. And let's go ahead and kind of build our table here. Now, before we do this, you'll notice that what this is this x minus 4. This is going to be a translation to the right 4 units of y equals 3 to the x. Now, we just got done with y equals 2 to the x, which looks something like, I think it looks something like this. So we'll probably get a graph of similar shape, just shift it over to the right. We're going to go ahead and go about this kind of the same way here. We're going to pick y's and calculate x's, starting with y equals 0. 3 to the 0 is 1, plus 4 is 5. And again, I'm picking y's and calculating x's. Let's try y equals 1. 3 to the first is 3, plus 4 is 7. Let's try y equals 2. I don't know if we'll get that one on there. 3 squared is 9, plus 4 is 13. Okay, these are getting too big. Let's start going the other way. Let's try y equals minus 1. 3 to the minus 1 plus 4, and let me write that one out. I'm just going to do this in decimal form here. This is basically 0.333 plus 4. That's 4.3. 4.3 is good enough. We'll just say approximately. Let me do one more here. If y is negative 2, then this is going to read 3 to the minus 2 plus 4, which is 1/9 plus 4. And I think what I'll do here is just get a decimal for that, if you'll humor me. That's 4.11. All right, so let's start sketching our graph here. So this thing goes through 5, 0. 1, 2, 3, 4, 5, 0. Goes through 7, 1, so 6, 7, 1. 13, 2 is, well, 7, 8, 9, 10, 11, 12, 13, 2. I guess I can kind of get that on there. It's looking something like this. Okay. 4.3 minus 1. Right, 1, 2, 3, 4. 0.3 is a third of the way over, minus 1. 4.11 minus 2. Now 4.11 is really close to the axis, and then minus 2. Now you see what it's doing is it's kind of approaching this line here. Let's kind of take a look at why. If you kind of look at this equation here, 3 to the y is positive for all values of y. And x has to be at least 4. It's 4 plus something. There's no value you can put in for y here that's going to make x equal, say, 2. X is going to end up being at least 4 because of this term. So this line right here, again, is like a vertical asymptote. And here's a sketch of our graph, looking something like this. There just is no value that you can put in for y here that makes this negative. So x has to be at least 4. In fact, it can't equal 4 either, because 3 to the y is some positive value for all values of y. So let's talk domain and range. The domain of this function. See, there's nothing over here to the left, so x has to be greater than 4. Strictly greater than, no equality, because again, there's no, when you look at this equation, there's no value here that you can put in for y to get a 0 out of this. And then the range is all real numbers, because this graph goes to minus infinity in this direction, and although it doesn't really look like it, it actually gets infinitely big to the right as well. because if you look here, you can put any value in for y you want. You're going to get a number out of this. You can put 100, a billion, a trillion, and there is an x value that corresponds to it. So I'm going to leave this or end this video right here. It's at 10 minutes, and I just wanted to make a quick video on how to sketch logarithmic graphs. And you notice I'm doing it without a calculator, really, without just plugging this in and trying to graph it. Now, furthermore, I don't think you can actually plug this into a calculator as it sits, because usually calculators just do, or at least a lot of calculators usually do base 10. So I'm going to save that for another video, how to actually plug this in to graph it using technology. So anyway, I'm going to end this one right here. I hope that this helps with how to sketch logarithms. Have a great day.